Can you see the screen? Online people?
Yes, sir.
Good, thank you. Okay, so we are ready to see the beauty of mathematics, right? Okay. So in the last class, we looked at certain equations, right? Especially you saw that field, finite field. So now actually, I think I forgot to give you a table for field with 4 number of elements. Though I sent you a link to see in my previous lecture, right? I don't know, some of you might have seen it. So I can look at it again. So here, okay, so we constructed field from consisting of A plus alpha B such that A and B are in Z2, right? And alpha is the equation of the root of the equation, right? Just like that from complex numbers, just like that you got complex numbers from reals, right? The same way, GF stands for Galois field. So I can again mention to you. So there were a couple of representations. One was 0, 0, 0, 1, 1, 0, 1, 1. This is bit representation of each element. There was also another representation 0, alpha, 1, 1 plus alpha. This is known as bit representation, and this is known as polynomial representation. Then we can, since 1 plus alpha is equal to alpha square, so I can write it like as a power of alpha, 0, alpha, 1, alpha square, powers of alpha. Okay, so these are the 3 representations. So normally in applications, so basically how do we work with these things? So suppose we want to implement something in computer science, right? Some file system or something. So what we do, we look at these elements, but then we add them as per this alpha business, you know. So we make a kind of table for their addition and multiplication, right? So how do we handle this addition and multiplication of bits? Okay, bits of certain length. Okay, so that is how we do it. So now let me make the table for you just to make sure that you understood the concept of field with 4 number of elements. So I'm going to make a table for addition. So 0 plus 0 is 0. 0 plus 1 is 0 plus alpha is alpha, and this is alpha square. 1 plus 1 is 0. 1 plus alpha square, and 1 plus alpha square alpha. 1 plus alpha is alpha plus alpha. Alpha plus alpha is 2 alpha. Ground field is 2, means 2 means 0, right? So it is 2 alpha is 0. And alpha plus alpha square is 1. Alpha square plus 0 is alpha square. Alpha square plus 1 is alpha square plus alpha is, and alpha square plus alpha square 2 alpha square, which is good. with respect to multiplication 0 1 alpha alpha square 0 1 alpha alpha square 0 0 0 0 0 0 0 1 alpha alpha square alpha into 1 is alpha alpha into alpha is alpha square alpha into alpha square is how much alpha cube is 1 you saw that then alpha square alpha square into alpha is alpha cube which is 1 alpha square into alpha square is alpha raised to power 4 is equal to alpha into alpha cube is 1 so it is alpha. Now we can check whether this is actually a field or not, right? So each element should have additive inverse, right? And of course additive identity we know is 0 here which is visible. So 0 is self-invertive with respect to addition. 1 is self-invertive with respect to addition. And alpha is self-invertive with respect to addition. Alpha square is self-invertive with respect to addition. So each element has its own inverse with respect to addition. Right? So we can play with the addition. Now we look at the multiplication. So we circle these multiplicative identities, right? 1, 1. So can we check? Every non-zero element should have multiplicative inverse. 0 को छोड़ देते हैं. Then we have 1 into 1 is 1. So 1 is self-invertive. Then go here. Alpha into alpha square is equal to 1. That alpha and alpha square are inverses of each other, right? And similarly the other one, right? So that means each non-zero element has an inverse. So we can play with multiplication as well. So this is a field. So we can play with addition, subtraction, multiplication and division. Done? कुछ चाय प्रॉब्लम सॉल्व करी थी कुछ पिछली बार लाइक ax square plus bx plus c is equal to 0 where a is not equal to 0 इसका जनरल सॉल्यूशन कुछ सोच सकते थे शायद सोचना मतलब हाँ आई एम सेइंग दैट ओके लेट मी I want a formula. Just like Shridharacharya formula. Do we have? Do we remember? You remember we have looked at these specific cases. We made 4 equations and then solved one of them. But do you think there will be a general formula or something like that? Think about it. So that equation minus b plus minus square root of b square minus 4ac divided by 2a is not going to work here. This is the beauty, right? The field. So, by the way, those who are little bit more advanced, adventurous, right? उनके लिए एक और चाय की प्रॉब्लम है बढ़िया मैं दे देता हूँ. So here if you have आपकी बार क्या है Z4 and Z4 is not a field, you know that. Then how will you solve? By the way, this is so beautiful. Normally what happens, there is a fundamental theorem of algebra which says that degree n polynomial will have n roots. Right? This is only true for field business. Ring में hold नहीं करता. डिग्री 2 की इक्वेशन के 3 रूट भी हो सकते हैं, 4 रूट भी हो सकते हैं, बड़ा काउंटर इंट्यूटिव है, दिस इज द ब्यूटी. So just for some time, if when you are feeling bit free or you want to enjoy with your brain, just see can you solve, right? Simple equation, high school student, high school mathematics, right? So okay, so then we can go to the next one. I think so are you able to draw table for field with 8 number of elements, or should I draw it here? I should draw it. By the way, this is right. Okay, so now we look at how to construct field with 8 number of elements. So we know how to construct field with 2 number of elements, 2 number of elements, 3 number of elements, 4 number of elements, 5 number of elements. 6 is not possible. 7 we know. This is Z2, this is Z3, this is Galois field with 4 number of elements, this is Z5. 6 is not possible. This is Z7. 8 will be 8 number of elements. Okay. So let me do one example for 8 number of elements. Though I mentioned these things in the last class, but just let us do some calculations so that you are more familiar with it. So we looked at degree 3 equation. Now A, B, C, D are over Z2. A is not equal to 0. There are two possibilities here, right? No, sorry, one possibility here. We are over Z2. Fine. One possibility here, 2 here, 2 here, 2 here. So 2 into 2 into 2, 8 possibilities. So I can write it down all of them. X cubed plus, so I think bx square plus cx plus d. Right? This is equal to 0. Why we are looking at degree 3 equation? I should tell you, because here it is Galois field with 8 number of elements, and 8 is nothing but 2 raised to power 3. So that 3 is coming from there. So we have to look at degree 3. If it is 2 raised to power 4, we have to look at degree 4. Right? If it is 32, 2 raised to power 5, we have to look at degree 5 equation. Like that, it will continue. Right? So let me write down all the equations. X cube plus x square plus x plus 1 is equal to 0. X cube plus x square plus 1 is equal to 0. X cube plus x square plus x is equal to 0. What else? X cube plus x is equal to 0. Then x cube plus 1 is equal to 0. X cube plus x plus 1 is equal to 0. दो और बची हैं, कौन सी? X cube is equal to 0 and अब इसमें कौन कौन सी काम की है, कौन सी बेकार है? दो काम किए हैं, राइट? बाकी सब तो everything else will have a root. This has root x equal to 0. This has root x equal to 0. This is useful. This has root x equal to 0. This has root x equal to 1 in the ground field, right? And this also has root x equal to 1. So we have this equation and this equation. As I mentioned, some of you can take this equation and some of you can take this equation. You will get field, but those are isomorphic, you know. By the way, there is a little bit more beauty. Sometime I will tell you about these things, but थोड़ा आगे बढ़ने पे होगा, अभी नहीं, ठीक है. So now let us take, I'll take just one equation, xu plus x plus 1 is equal to 0. So I am constructing field with 8 number of elements is equal to a plus b alpha plus c alpha square such that a, b, c belongs to Z2. And alpha is the root of the equation alpha cube plus alpha plus 1 is equal to 0. Alpha is root of the equation x cube plus x plus 1 is equal to 0. I can take x cube plus x square plus 1 is equal to 0. Some of you are adventurous, so you can take that equation, right? And do everything, whatever we are doing. So now you see 2 possibilities for A, 2 possibilities for B, 2 possibilities for C. Total 8 number of elements, 8 elements will be there in the field with 8 number of elements, right? And we can have all those bit representation 0, 0, 0, 0, 0, 1, and all those 8 possibilities. Then we can have polynomial representation and we can have power of alpha representation. तो मैं polynomial और bit छोड़ देता हूँ तुम्हारे लिए, that is okay. मैं power of alpha लिख देता हूँ. कितने होंगे पावर? एक और होगा? Where alpha satisfies this equation, right? And note that alpha raised to 7 will be 1 automatically. You can check that, right? So now keeping this thing in mind, you can make the table for addition and multiplication. But I think we need to do some calculations first. So can you tell me what is the value of alpha raised to 4? Alpha into alpha cube is equal to alpha plus 1, alpha square plus alpha. हम रिवर्स जा रहे हैं ना, रिवर्स इंजन जो चाहिए वो निकाल लेते हैं, बाकी हम क्यों वरी करें, राइट? Alpha raised to 5 will be alpha cube plus alpha square, right? Alpha cube is nothing but alpha plus 1 plus alpha square. So alpha raised to 5 is this quantity. ये सब समझ में आ रहा है, मैं कुछ कहानी बोल रहा हूँ? कहानी की तरह ही समझ में आना चाहिए वैसे. So you don't have to memorize, it should come automatically. क्या चीज 0 होगा? This no, because here alpha cube plus alpha plus 1 is equal to 0. This is alpha square plus alpha plus 1. Okay. Then alpha raised to power 6 will be alpha raised to power 5, which is alpha times alpha plus 1 plus alpha square is equal to alpha square plus alpha cube is equal to alpha square plus alpha cube is alpha plus 1 is equal to alpha square plus 1, because 2 alpha is 0, right? Anything times 2 is 0. Okay. And then alpha raised to power 7. Alpha into alpha raised to power 6 is yes, sorry. Alpha plus 1 plus alpha is equal to 1. Right? Now it is easy to make those tables, right? Now you can do all that. Write down everything in the powers of alpha, and then you can do the calculation for addition and multiplication and check that or satisfy yourself that every element has additive inverse, right? So, and every non-zero element has a multiplicative inverse. Then this is a field with 8 number of elements. So these calculations will be a little bit different when you consider the different polynomial alpha cube plus, so x cube plus x square plus 1 is equal to 0, right? So now, as I told you, somebody should do that calculation and this calculation, make the table and tell me what is the difference, right? So this is known as here seventh root of unity. It's not cube root of unity, but seventh root of unity, right? Actually, this kind of calculation will be useful for factorizing a polynomial x raised to power n minus 1 is equal to 0. How do you factor it? X raised to power n minus 1 is equal to 0. So x raised to power n minus 1, you can solve over reals or complex. यहाँ पे थोड़ा सा विचित्र कहानी होती है, right? So that is something beautiful. So you can look at it, or maybe at a later time see how do you factorize x raised to power n minus 1, right? X raised to power n minus 1. So you have to find the roots of the unity basically, I am just saying, right? Otherwise complex में क्या होता है, सर्किल के ऊपर सब अरेंज होते हैं ना, रूट्स ऑफ यूनिटी. यहाँ भी वैसे ही कुछ है, लेकिन complex numbers नहीं है, right? So no complex numbers here. So things are a little bit different. Yes. अरे आवाज नहीं आ रही है, हाँ थोड़ा तेज बोलो. ZF4, yeah, x square plus x plus 1 is equal to 0, yeah, right? Correct. So in the field with 4 number of elements, alpha cube is equal to 1. Here alpha raised to power 7 is equal to 1. If you go for higher fields, some other power of alpha will be 1. Right? So some other power, so basically what happens, you start with power representation like this and see, you can count. If there are 8, there are 16. Suppose there is field with 16 number of elements. So which power will be 1? 15 or 16? 15, right? So you know how everything is going. Everything is very systematic and very beautiful. I mean, you can see that, right? Okay, so I think इतना ही करना था मेरे को फील्ड में. बाकी तो you can do, मैंने कुछ assignment दिया है, right? Find the square root of 1101 or whatever over field with 16 number of elements. See, you have to first construct field with 16 number of elements by taking a degree 4 polynomial. Polynomial would be x raised to power 4 plus x plus 1 is equal to 0. You can see that, right? And then you can construct the field with 16 number of elements, do the calculations. You can divide to, representations like binary representations, take a square root, whatever you want, you can play, right? Because field is for you to play with numbers. That's all. Okay, so now I hope we should be able to cover. I have planned a couple of things, but anyway. So now I want to apply some of these ideas beautiful thing. Like suppose you have seen, you have bank account, right? Somewhere. You access your bank account all the time. So whenever you access your bank account, I can show you here maybe. Okay, you go to ICICI Bank. I have bank account in ICICI Bank, right? You can go to your own one. Now on the website, you see little lock here, right? What is that lock? Secured is fine. But what is the beauty? What is the mathematics? The beauty of the lock is, I will show you. Let me see if I can see the certificate here. You see these numbers? This is the beauty of this lock. Actually, it employs an algorithm known as RSA algorithm. Rivers, Shamir, and Edelman, three mathematicians. Rivers was professor at MIT, and Shamir was also there. I mean, Shamir is, they are all working in biology, by the way, these days, And Edelman was kind of programmer at that point of time. He wrote, he tested the algorithm actually for various things. So, what are these numbers and so on? I will tell you. I think the last question in your assignment is to generate these kind of numbers. Okay, not for now, not for the large, but just for a toy problem, right? So this RSA crypto system you use every day, but you should know the beauty of RSA, right? How it works. So I'm going to explain that in this class, how it works, using the same modular arithmetic business that you saw, integer modulo n, right? Okay, so that is the thing. By the way, I can just say to you one thing. RSA is known as public key crypto system. So what is private key crypto system or public key crypto system? There are two kinds of crypto systems. Private key crypto system, what happens? You have something, you encrypt it with your key, and somebody will decrypt the data using the same key. And this is private key or symmetric key crypto system, right? Because same key is used. In public key crypto system, you encrypt something with your private key and then public key. How the business is there. I mean, it's very simple. There is a very simple story, I should say, the motivation. Suppose there is a corrupt postal system, right? Corrupt postal system, and you want to send some important letter to your friend, and what you have, a briefcase. You can put your letter in the briefcase, lock it. So you have the key with you, and send it. So it's safe. But how to send the key now? If you send the key, postman will take the key and open the briefcase and read your letter. How to solve this? This is very nice problem. How do you solve it? की तो भेज नहीं सकते हैं, प्रॉब्लम है. 1 मिनट के लिए सोच सकते हो, then I can give you the answer. Corrupt postal system है, right? You have one key, you can lock, and you can send. But if you send another, if you want to send the key, you can key in another briefcase and another lock, but then again that key will be there with you. problem. And now comes the beautiful thing. What is the beautiful thing? What you can do here, take the letter, put it in the, so listen it very carefully, solution. Take the letter, put it in the briefcase, put your own lock, keep the key with yourself, send it to your friend. The friend will put his own lock with his own key. His key will remain with himself, and then it is send it back. So now while coming back, there are two locks. Now this guy will open our own lock. One lock is there, and then again you can send it back, and the other person will open with the other lock. So that is a beautiful. So right. So these kind of ideas gave rise to this public key cryptography. Duff and Hellman, actually introduced this public and private key business in 1977. Although this was known earlier to British mathematicians, but they have not disclosed anything until 1979. Yes. No, but that is not the beautiful solution, right? So basically, so basically, this kind of idea of public key crypto system is pretty useful. You use every day. So what happens normally, it is slow. So we use symmetric key crypto system, means you take the data, and there are two popular algorithms like AES is commonly used now. Earlier it was DES, digital encryption standards. Now advanced encryption standard is used, right? So you encode data using AES, and for sending key you use public key crypto system. So that is a mixed cryptography or hybrid cryptography that is used commonly, right? It has wider applications, for example, digital signatures and so on and so forth. So once you do a full course on cryptography, which you must do because security is very important, right? Whenever there is a data, you can hack it. If you can hack it, so you can make money, right? I mean, you can do all kind of things. So it's very, very important. Anyway, so let me do some basic building blocks. So before actually telling you about RSA crypto system, I am going to cover some elementary number theory. Number theory is, is very beautiful thing, right? Because mathematics is queen of all sciences. Number theory is crown of the queen. And in that crown, we are, is quite useful. By the way, what are the gems on the crowns is known as quadratic residues. We'll talk about it sometime later on in the course. Okay, so okay, so now I think but most of these things you might be knowing, or but we need to put in a perspective of number theory. And so if you want to master mathematics, there are 4 branches. What are those 4 branches? Number theory, calculus or analysis, basically in most advanced version, algebra, and geometry. These are the 4 branches. So you should have a strong mathematical education in that way that you understand these things. Basically, the purpose of education is that you should be able to read any damn thing on this planet, right? If you have got that ability, you are done, right? Degree नहीं चाहिए उसके लिए, right? उसके लिए चिंतन चाहिए, आत्मचिंतन, right? So you can sort of read anything. That ability is very, very important. So anyway, let me cover. So one very beautiful book is by G.H. Hardy. मैंने बोला था तुम लोगों ने कैलकुलस की किताब भी G.H. Hardy से नहीं पढ़ा था, राइट? G.H. Hardy's must. So number theory is also by G.H. Hardy. G.H. Hardy and Ramanujan has a strong connection. You might have read somewhere, right? So I think you can actually look at these things. That book, it's a very beautiful book. Anyway, so this is set of integers. Okay, so set of integers. Okay, now with these integers, what I can do? There is a, if I take a positive integer n, a greater than 1, one theorem that is very important is known as fundamental theorem of arithmetic. What is this? That n can be written as product of prime factors. For example, 16 is 2 raised power 4, 15 is 3 into 5, right? Twenty is what? 2 into 3 into 5. So it's very important thing. Oh, that is 30, right? आप सही है? मेरे को कई बार मति भ्रम हो जाता है. Means, you know, I say that this is 30, then I can, you know, look at the. Anyway, so that is a problem, you know, when you become old. So the thing is that this factorization business is very important. Do you want to earn money, or you want to earn fame? If you want to earn money and fame, so for this factorization, RSA company, that RSA crypto system, those who have developed RSA crypto system, was giving money up to $250,000 for just factorizing integers. So I can maybe show you that list, you know, it's very. This is the list. 100 decimal digit, $1,000 prize. Somebody has taken 110 decimal digit factorization. So I can show you. This is the number, you see. This is the number. This is the prime factorization of the number. These are two prime numbers. You have to do a very simple thing. You think you are very good in programming, write a computer program to do this. Then you see something else. So something else which is not factored it is this. This is last 2020, February 28. RSA 260 is still not factored, you see. This one. You have to write a small computer program, right? Prime factors. Right? Beautiful challenge. No, this is not a prime number. It is a product of two prime numbers. It is a product of two prime numbers. You have to find those. So these are all open. As you can see that $100,000, $75,000. $200,000, $150,000. They are factored into two, right? So basically, this is a challenge, right? Sometimes they have used bunch of computers, you know, in parallel to factor the number. Or if you know some jadugari or say some magic, or you know, provide the factor intake, you will be famous. You can write this number is factorization is this. Use some Vedic mathematics or whatever you know. right? So this is another beauty, right? So now, so this is fundamental theorem of arithmetic. So why actually they are giving prize? Now they have stopped because there are quantum computers actually. Quantum computers can factor these numbers easily. Okay. And so still, although we are using RSA crypto system, because the difficulty of cracking the RSA crypto system is based on this problem that factorization is a difficult problem. How difficult is, any guess? Is Brahmand ka pratek kana, every particle of this universe is this computer that you use today, and it is trying to factor, suppose 2000 digit number for the lifetime of the universe, is still that will be insufficient to factor a 2000 digit number. That is a difficult problem. That much difficult problem is this. This is not said by me, by Umesh Vajirani, who is a famous professor of computer science at University of California, I think Berkeley probably, yes. Okay, so that much difficult it is, right? If every particle of this universe is classical computer and computing for the lifetime of the universe, trying to factor this number, that will be insufficient. Now you see the challenge and the beauty, right? How to factor. Anyway, so now we go to a couple of notations. Suppose A and B are integers. Say A divide B if there exists an integer k such that B is equal to AK. So I use a lot of notation shorthand, because it's easy. I don't want to write too many things. I hope you understand. This is the notation for such that, right? B is equal to AK. Okay. And this is for there exists. If there exists K integer such that B is equal to AK. A number D is known as common divisor if D divides A and D divides B, both, right? GCD of two numbers, largest of the common divisor. GCD निकालना तो बचपन से सीख रहे होगा, right? From class 3rd, 4th, 5th. So I hope you know. But from a computer science perspective, one can ask a question: what is the complexity, number of operations that are used to compute GCD of two numbers? There you have to think. And if you love Art of Computer Programming by Donald Knuth, you know the answer. Or, think about it, you search Google, you will find anyway. So basically, there is a formula. If A is something like P1 raised to power alpha 1, P2 raised to power alpha 2, alpha k, P is equal to P1 raised to power beta 1, P2 raised to power beta 2, Pk raised to power beta k. Because numbers can be factorized, assuming that they are greater than 1, so I can factor them by fundamental theorem of arithmetic, right? Once we are able to do that, then GCD of A comma B, P1 raised to power minimum of alpha 1 comma beta 1, P2 raised to power minimum of alpha 2 comma beta 2, and so on, Pk raised to power minimum of alpha k. What about LCM of A comma B? maximum will be there. Very good. So I think I leave it. If GCD of A and B is 1, then we say that A and B are relatively prime. Okay. Also, another fact, if A and B are integers, and of course, both are non-zero, I can assume, suppose. There exist S and T integers such that GCD of A comma B is equal to S times A plus T times B. GCT is a linear combination of A and B for some integers S and T. This is a fact, right? I think at this stage you can try to look at some examples and see this is the case, right? Or if you want, you can try to prove it anyway. If A divides B into C and GCD of A and B is 1, then A divides C. If I want to divide, so if A divides B in C, product of two numbers, then and GCD of A and B is 1, then obviously A will divide C. This is something not very difficult to observe. Okay, now suppose n is a positive integer. Z plus means positive integer, right? A and B are integers. Then we write A is congruent to B mod n. If A minus B is multiple of n, or if n divides A minus B. A is congruent to B mod n. You might have seen these things earlier, right? Or maybe not, that's okay. Now I'm going to prove one result or fact. If GCD of A and B is 1, then the equation AX congruent to B mod n is solvable and its solution is unique. Again, I use notation, this notation I use for uniqueness, unique. If GCD of A and B is 1, then A is congruent to B mod n is solvable. You can solve this equation, right? And the solution is unique. Sorry, this is n. I'm sorry. GCD of A and n, not B. GCD of A and n. Okay, so proof is very simple. So we are doing it. If GCD of A and n is 1, this implies that there exists S and T such that 1 is equal to AS plus NT. Correct? अभी fact हमने देखा था. If GCD of A and n is 1, there exists integer S and T such that this linear combination is equal to 1. Right? Multiply both sides by B. So B is equal to BAS plus BNT. Reduce it to modulo n. So this portion will go off. You are left with B is congruent to ABS mod n. This implies that X equal to BS is a solution because it satisfies the equation, right? X equal to BS is a solution. AX, right? x equal to bs is a solution. So what about uniqueness? I think that's enough. So uniqueness तुम लोग चाय पे अपना सोचना. Suppose there are two solutions x and x prime, and that means ax is congruent to b mod n and ax prime is congruent to b mod n. That means what? A times x minus x prime is congruent to b mod n by subtraction, right? Or by calculations. Then you can do some magic to get the answer. They are unique. सोचो, नहीं तो फिर मैं करूंगा. आई थिंक बहुत हो गया अभी, ज़्यादा बोर नहीं करना चाहिए, राइट? तो वी विल मीट इन द नेक्स्ट क्लास.